Hey y'all, today we're going to be learning about graphing linear equations. So when graphing linear equations, there's two things that we want to look for. As always, we want to look for the slope, and we want to look for the y-intercept. So just as a recap, if this is my equation, y equals 2x plus 1, our slope, our m, is always the value in front of x, and our y-intercept is always our b value, or the number being added or subtracted. Okay, so now that we kind of know what we're looking at in our equation, which hopefully you should know what you're looking at in a linear equation by now, let's kind of go through our steps. So our first step every single time is going to be to plot the y-intercept on the graph. So the y-intercept is always going to serve as our first point when graphing a linear equation. So our y-intercept is positive 1. So on the y-axis, and I'm graphing on the y-axis because it's a y-intercept, I'm going to plot a point right here at positive 1. Okay, so that is my step 1. Step 2 is that I'm going to use my slope. Remember, our slope is composed of rise over run to plot a second point. Or even more, point. So we already have our y-intercept on this one. So our y-intercept is 1. Right, our slope, if you remember, is 2. Okay, now 2 is a little hard when we're talking about rise over run because it's just 2. It's just a whole number, so we don't have those two parts of the fraction. But we can always change 2 is the exact same thing as 2 over 1 because dividing anything by 1 isn't going to change the number. It's just going to keep it exactly the same. So now my rise is on top. So my rise is 2 and my run is by 1. So from my y-intercept, I can rise by 2 and then run by 1. So that's where I'm going to put my next point. And you can be good with 2. Once you get 2 points, that's enough for you to graph your line. But if you're like me and you want to be sure that your line's pretty straight, you can go and you can graph a couple more lines, just repeating that rise over run. So up 2 to the right by 1, up 2 to the right by 1. And then if we're going the opposite direction, if we're going to the left instead of to the right, we just do it backwards. So down 2 to the left by 1. And so on and so forth. Like so. Okay. Now, very last thing in step 3 is to draw a straight line. Through the points. So just like I had on my other ones over there, I have my points. And if you're using Kami, y'all, Kami actually has, if you go click over here on the shape, it has a nice straight line drawing tool. So we draw that straight line, and then the last thing we want to make sure that we add on to our graphs, okay, is we want to make sure that we add on arrows. Okay, because the arrows means the graph is going to keep going in both directions. Okay, and that's important. So add arrows on the ends. Okay, now if I wanted to, let's kind of talk about this graph. Let's talk about some key features. So first off, my slope. Okay, our slope was 2. My y-intercept was 1. Okay, my function as we go from the left to the right, does it look like it's increasing in value or decreasing value? Well, it has a positive slope. It's increasing in value. So it is increasing. And then its domain, okay, if I'm continuing to the left and continuing to the right, if I keep continuing on forever, okay, that's going to be all of our numbers, yes, all of our real numbers. So I could write it as all real numbers. I could write out all real numbers in words, or you could write negative infinity is less than x, which is less than infinity. So you can write an interval notation as well. Now, likewise, my range, okay, same thing. If I'm going up forever and down forever, it would also be all real numbers. Okay, and for our lines, our domain and range is never going to change because even though we're going to change the slope, we're going to change the y-intercept, our lines are always going to continue in both directions. So the domain and range for all lines forever are always going to be all real numbers. Okay, so let's look at another one in practice. Okay, example 2, our slope, okay, -2. So our slope is -2, but I'm going to go ahead and change it to -2 over 1. Okay, our y-intercept, +7. So our y-intercept is 0, 7. Okay, now going through the 3 steps. So step 1, plot the y-intercept. Step 2, okay, use the slope, rise over run. So I'm rising by -2, which means I'm going down by 2. So down 1, 2, and then to the right by 1. And this time I'm just going to do it with the 2 points. Okay, see if we can make it work still. And then last but not least, third step is to connect the 2 points. Oop, that was good, and then I got kind of off. There we go. And then add my lines onto the end. Just like so. Okay. Now this one, slope and y-intercept, we already got that. Okay. X-intercept in this case, if we were to look at it. Okay. Still not really a clear x-intercept, so we're not going to worry about this one. But this one, would it be increasing or decreasing? Well, as we go from the left to the right, this function would be decreasing. Okay, so something you should notice, increasing lines have a positive slope, decreasing lines have a negative slope, and it's going to hold true to that no matter what. Okay, then my domain, we talked about this last time, it is always all real numbers because it continues on, and my range, always all real numbers. Okay, let's look at another one. So example 3, we have y is equal to 3/2 x minus 1. Okay, so slope in this case is 3/2. Y-intercept in this case is -1. So 0, -1. So then we graph y-intercept first, so a point here at -1 on the y-axis. Then I follow my slope, so I'm going to go up by 3, 1, 2, 3, run by 2, 1, 2. And then last but not least, graph my line. And add my arrows onto the end. just like so. Okay, same thing, talking about our key features. So increasing or decreasing, this one would be increasing. Increasing. My domain would still be all real numbers, and my range would still be all real numbers. Okay, pretty straightforward. All right, last but not least, we have example 4. Example 4, we have y is equal to 6. Okay, so this one's a little bit different, but let's talk about it. Okay, so our slope. Do we have a number in front of x right now? No. Okay, we don't have a number in front of x, so we don't have a slope because our slope would be equal to 0. Okay, my y-intercept, okay, well, y is equal to 0, so my y-intercept is just 0, 6. Okay, now to actually graph this, I'm going to start by plotting that point at 6, so nice little point right here at 6. Okay, now my slope is 0, so my slope of 0, okay, that's our no slope, which makes it a flat line. Okay, so I'm just going to draw a straight horizontal line. So right through here, and it has to go through that y-intercept at 6, and I'm still going to have my arrows stuck on there at the end. So let's talk about those key features. Okay, so we have our slope, we have our y-intercept. We don't even go through the x-axis, so we don't have an x-intercept to worry about. Okay, our increasing or decreasing, well, if the slope is 0, then I'm never going up or down. Okay, so we would say neither, or you could say it's just constant. Okay, then my domain, still all real numbers. My range this time, okay, I'm not going up and down forever. I only have one value in my range, and it would just be 6. So I only have that one value for the range. So I did kind of lie. If you have a straight horizontal line or a straight vertical line, whichever type it is, so like range has to do with y values, my equation is y equals, so that's going to change from all real numbers to whatever the equation is. Okay, y'all, and that is kind of our basic graphing lines.